We are going to be working on lesson 8.5 today. So we are going to be looking at algebraic expressions and using different properties to determine if they are equivalent or not, or making an equivalent expression. So this lesson has a lot of information in it. So if you need to break it up, go ahead and do that. Watch it for 20 minutes, take a break, come back, finish it. So this is really important information that is going to help us understand if the mathematical expressions are equivalent following mathematical rules. So when you have a paper and a pencil and are ready to do some problems to help us with task 1, let's go ahead. So we are going to do a few similar problems, and then I'll have you try yours on task 1. So we're going to evaluate, again, that means to find the value when 3x plus x cubed, x equals 4. So the first thing we want to do is plug it in. So this becomes 3 times 4, not just 34, plus 4 cubed. So we still have to follow our order of operations. So we don't have any groups, but we do have exponents. So this is 4 times 4 times 4, 4 3 times. This one is 3 times 4, but this is 4 3 times. So they are different problems, and we have to be aware of that. So 4 times 4 is 16, times by 4 is 64. So we have 64 plus 3 times 4. So I want you to pause the video and see if you can finish that problem. So we have 3 times 4 is 12, and then we're going to add on 64, makes that 76. So here we have 76. And then we're going to see if this is equivalent. So evaluate 6 groups of 3x when x equals 4. So we have 6 groups of 3 times 4. So 3 times 4, we do our groups first. 3 times 4 is 12. And then we're going to do 6 times 12. Let's go ahead and finish that and decide, are these expressions equivalent or not? So 6 times 12 is 72. So these expressions do not have an equivalent value when x equals 4. So we're just going to use the strategies we've been using from the past few days, plug in what x is or whatever the variable is, solve using order of operations to see are they equivalent or not. So let's try another one here. So go ahead and plug in 2 for x. So here we have 2 groups of the sum of 3 plus 7. So remember, when we're using a sum, we need to have parentheses around it, and then we're going to square that. So we still have to follow our order of operations. So G is for the groups or parentheses. So we want to do the parentheses first. So here we have 2 groups of 10 squared. So we don't have anything else in the groups that we can do. So now we're going to use our exponents. So this does not mean 10 times 10. So write out, what does 10 squared look like? That problem is 10 times 10. We have 10 2 times. So 10 times 10 is 100. So now we have 2 times 100 is 200. Okay, so now we need to evaluate this one. So x still equals 2. So we have x cubed, parentheses, 50 divided by x. Let's go ahead and plug in 2 for x. So here we have 2 cubed, parentheses, 50 divided by 2, close parentheses. Okay, so we need to do what's in our groups first. So here we have 50 divided by 2. So if I take 50 and cut that in half, we get 25. So now I have 2 cubed times 25. So we don't have any more groups. Our groups are done, but we do have exponents. So we need to do 2 cubed. So 2 3 times, 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. And then we're going to do 25 times 8. So go ahead and try 25 times 8 to decide, are these expressions when x equals 2 equivalent or not? So when I have 25 groups of 8, that is 200. So these expressions do have an equivalent value when x equals 2. Hey, here we're going to find the perimeter of this rectangle. So both of these sides are f, and these sides are half of f. So this tells us to find the perimeter. So x equals 2. So we have 2f's plus 2f squared. So f, 2f's, sorry, let me start that over. 2f's, and then we have 2f divided by 2's. And this should say f equals 2. So we have 2 times 2 plus 2 groups of 2 divided by 2. A lot of 2's here. So we still need to follow gems here. So groups first. 2 divided by 2 is 1. So now we have 2 times 1 plus 2 times 2. So we don't have any exponents. So now we're looking for multiply or divide. So here's our first one. 2 times 2 is 4. Plus 2 times 1. So now we're going to multiply. 2 times 1 is 2. So 4 plus 2 is 6. So this has a perimeter of 6 units. So another way they're saying they can solve this is to use 3 f's, because here I can see 1, 2. Here's half of an f and half of an f. 2 halves make a whole, so we have 3 f's. So that means 3 times 2 is 6. So yes, these two expressions are equivalent and will tell us how to find the perimeter of this rectangle. So go ahead and try the problems on task 1. Be sure to follow your gems and replace them and write them down to do them, and then go answer the questions on the computer. And when you are ready to do task 2, come on back. Hey, so this word equivalent, that was a very crazy, not straight line. Move a little better. So we can hear that word equal in here. So equal expressions are expressions that have the same value. So no matter what, even if I put a different number in here, as long as we said these are equal. So if I put a different number in here for x, as long as I put the same number, they would still be equivalent. Where this one, it's not going to be the same number, so they are not equivalent. So it has to have the same value replaced into the variable. So of course we can't check every possible number, right? That would take us a really long time to go through and be like, does 1 work? Does 2? Does 3? And we could do that with 3.5 and 3.75, and we'd be there forever. So there is other ways to show that expressions are equivalent. So we can use different properties of operations to rewrite the expressions and to see if they are the same. So let's take a look at some of those properties that we can use to rewrite expressions. So the first one is the commutative property of addition. So when I hear this word commute, so when people drive to work, they commute to work. So they drive to work, they commute to work, they drive home, they commuted back home. So we can do this when we are adding. So what that means is we can change the order of the numbers and it will give us the same answer. A plus B is B plus A. So if A is me going to work and B is me going home, if I go the same way, it's going to be the same thing. Whether I go to work and then home or home then work, it's the same distance. So an example here, 14 plus 16 is 30. But I can flip those around. I can commute these and change which one comes first. 16 plus 14, those still equal the same answer. So we can change the order when we are adding, and it will not affect our answer. We also can do that commutative property when we are multiplying. A times B is the same thing as B times A. So changing the order of multiplication does not change the product. So an example, 3 groups of 4 is 12, 4 groups of 3 is still 12. So when we add and we multiply, we call that the commutative property that says we can change the order without affecting the answer. So my question for you is, why isn't there a commutative property for subtraction and division? So if I had the problem 4 minus 1, so if I did 4 plus 1, I can change that around and say 1 plus 4, and they both equal 5. How come I can't flip around 4 minus 1? Or if I have 12 divided by 3, how come I can't flip that around? So if I did 1 minus 4, that would equal negative 3. And that is not the same as 3. Those are opposites. 12 divided by 3 is 4. If I did 3 divided by 12, that is 0.75. So, or 3/4. So here we have the 3 and the 4, but these are opposites. So subtracting and dividing, it matters which one comes first, and we can't just change that. It gives us a different answer. But when we multiply, if I do 3 times 4, that's 12, and 4 times 3 is also 12. So when we add and when we multiply, we can commute those numbers and change that order. So another one we have here is the associative property of addition. So when you associate with someone, you are grouped together with them. So when you are adding numbers, just so we can see A plus B plus C, we can group A and B together, or we can group B and C together. And it's not going to change our answer. Let's take a look here. So here we have 5, 6, and 3. So if I do 5 plus 6 first, that's 11, plus 3 more is 14. If I group the 6 and the 3, if I associate the 6 and the 3 together first, so I would do 6 plus 3 is 9, plus 5 more is 14. When you're just adding on numbers, just like the commutative property, it's not going to matter which ones we do first. When all you're doing is adding, you'll get the same answer. So it doesn't matter which ones you associate together, as long as all you're doing is adding. As soon as you throw another operation in there, then it does matter what you do first. That same rule applies for multiplication. It doesn't matter which ones we associate together as long as you're just multiplying. So we can do A times B, then C, or we can do B times C, then times A. We'll get the same product. Let's take a look. So we could do 4 times 5 are associated together, makes 20, times 3 is 60. We can associate 5 times 3 together first. 5 times 3 is 15, times 4 of those is still 60. So we can change things around and commute them when we're just adding or just multiplying. We can also associate different parts of the problem together to make the same, to see if they are equivalent or not. So just like there was not a commutative property for subtraction and division, there is not one, or there's not an associative property for subtraction or division either. So if I have the problem, let's do 14 minus 7 minus 2. So let's try associating 14 and 7 together first, and then we'll try to associate these 7 and 2. So I'm just moving the parentheses to associate these, not saying do these first. So if I do 14 minus 7, that is 7. And then we're going to minus 2 is 5. So here we have to do 7 minus 2 first is 5. 14 minus 5 is 9. So when we associate different numbers in subtraction, it gives us different answers. And the same thing is going to happen in a division problem, where when we multiply and divide, it didn't matter which ones we did first, we still came up with the same answers there. So when our answers should be getting bigger, multiplying and addition, that works, but getting smaller did not seem to work. Okay, one more property here is called the distributive property. So when this only works when you are multiplying a sum or a difference. So when you're multiplying something in parentheses that's been added or subtracted. So multiplying A times B plus C, the sum of B and C, the difference of B and C. So remember, when we have the word sum and difference, those need to go into parentheses to say, do this first. This is a group that needs to go together. So what we can do here is we can give these numbers. I can give A to B and come up with A times B. And I can give A to C and come up with A times C and just add those together. The same thing works for subtraction. A times B, then we're going to minus, keep your same sign, A times C. And then now we're just finding each group and then doing the operation instead of combining them first. So let's take a look at that with some numbers here. So we have the sum of 3 plus 2 times 4. So we're going to give the 4 to the 3. So 4 times, so we can make that. So, well, let's just start 4 times 3. And we're going to add on 4 times 2 and see what we get here. So 4 times 3 is 12. 4 times 2 is 8. And we add those together, we get 20. So let's try that without using the distributive property. 5 plus 2 is 5. 5 groups of 4 is 20. So you can see using that distributive property gave us the same answer. Sometimes using the distributive property can help us do problems more easily in our heads. So I gave this 4 times 3 is 12, and I gave this 4 times 2 is 8, and I still add those together is 20. You can also go the opposite way in the distributive property. So this has already been distributed. So we can look at this and say, what do these have in common? What factors does these multiplication problems have in common? So they both have a 4. So you can pull out the 4. So what are we left with here? 3. What are we left with here? Plus 2. And we can see using that distributive property that these are actually going to give us the same problem. So when I use that distributive property, I either turned this problem into this one or turned this problem into this one. So using that distributive property, we can see if expressions are equivalent without even doing them. So let's do a few practice on those distributive properties. So remember, it only works when the terms are added or subtracted, then multiplied. So we're going to give the 5 to the 6, give the 5 to the 4. So this makes it 5 times 6. See if you can finish that problem there. Plus 5 times 4. So we could even keep going and make this 30 plus 20 here. So we could just skip straight to 5 times 6 and 5 times 4. So we're distributing. When you distribute something, that means you give the factor to it, both parts. A distribution center is a place that makes products and just gives them out to the companies. So we're giving the 5, we're giving the 5. So let's try another one here. So this time we have variables. and we don't know what our variables are. So this is where this distributive property really comes in handy, is when we can't just solve and do these equal each other. So we can rewrite the problems to see if they're equivalent. So we need to give the 3 to the x. So now we had 1x times by 3. Now we have 3 x's. We're going to minus, we have 3 groups of n minus 3n. So we can rewrite the problem to give the x to both parts. So let's try one more here. So if we have this here, we can give the 4, give the 4, give the 4. So since they're all added, we can give the 4 to all parts. So here we would have 4 times 5 plus give the 4 to the 8, 4 times 8, plus give the 4 to the 6, plus 4 times 6. And then you could see if this was equivalent to a different expression. So we're going to do some going backwards now, and we're going to pull out the factor that they have in common. So I can see I have things that are multiplied, and then they're added together. So I can pull out a factor. So what do these two parts, these two terms, right? Here's our addition sign. So here's a term, and here's a term. What do these two terms have in common? They both have a 9. So we pull the 9 out. So I'm left with 3 plus 4. Okay. So here we have 32 and 16. So we have these two terms here, 32 and 16. So we need to think of a factor. We want to find the greatest common factor that they share, so that they have in common. So I'm going to think of things that make 16. So 1 times 16, can 16 go into 32? Yes, it can. So 16 is their greatest factor. So I'm going to pull out 16. What am I left with here? 32 plus, so, whoops, that's not what I wanted to do. Ignore that. That was a mistake. So we're pulling out the 16. So 16 times what? Because we pulled out this factor. So 16 times what is going to equal 32? So 16 goes into 32 2 times. So we're giving factors here. 16 times what will equal 16? Well, we said right here it's 1. So we could rewrite 32 plus 16 as 16 groups of 2 plus 1. So 16 times 2 is 32, plus give the 16. 16 times 1 is 16. So we can see these are equivalent here. Okay, now we have 3 x's plus 9 r's. So here's our adding sign. So we have the term 3x and 9 r's. So we're looking here, what do these have in common? So the x and the r are not in common, so they're going to stay there. So what do 3 and 9 have in common? So these both have a factor of 3. So we want to pull out the 3. So what's left here is x. So when I do 3 and give it to the x, that will make 3x here. So I always like to check myself. Now, how would I get from 3 to 9? 3 times 3 with the r. So if I give this here, 3 times 3 is 9 r's. So equal, so these are all equivalent. So even though we don't know what x and r stand for, we can still use that distributive property. Okay, our last thing we can do here to see if expressions are equivalent is we can combine like terms. So remember, terms are things that are added or subtracted. So terms that you can combine, so like terms have the same letter for the variable. So I can't combine a B and an A. Those are different. They're not like each other. So I can combine A's and A's. and they have to be raised to the same power. So I can't combine something that's squared and cubed. So here we have A, and they're both raised to B's. So they're the same. So I have two A B's. Let's take a look here at these. So 3 and 5, they're both numbers. They're added together. I can easily just combine those. So here I have 7 x's and I'm subtracting 6 x's. They have the same variables. Neither of them are raised to a power. They're just to the first power. So 7 x's take away 6 x's just equals an x. You can put that 1 coefficient, but you don't need it. We just know there's 1 here. Okay, and here, so more complicated ones. We have 3 w's plus 4r squareds plus 9 w's plus r squareds. So I'm hearing we have some different variables in here. So we can only combine things that have the same variable and the same power. So here's a w and a w, and they both don't have a power with them. So I can put those together. 3 w's plus 9 w's is 12 w's. So here I have an r, and they're both squared. So I can put those together. So I can say 4 r's plus 1 r is 5 r's squared. So let me add on, let's say we have 6 r's. So I don't have any more just plain old r's. So that would just be 6 r's. So I can't combine these r's, even though the variables are the same. They don't have the same power, so they are not like each other. They're very similar, but they are not the same. So I can't put those together. And now notice when I did these powers, I didn't change the power. They were still just squared. That didn't change. It's not all of a sudden to the 4th. It's still just going to be r squared. So those are several things. Now, that was a lot of information, but those are several ways that we can change expressions around to see if they are equivalent, even if we don't know what the variables equal. So let's try some out here now. So here we have our list of what they are, and we want to decide is a plus 2b's times 4 plus 4a and 8 groups of a plus b the same. So we're going to start with this first one here. So we have 4 groups of a plus 2b plus 4a, and they turned that into 4 a's plus 8 b's plus 4a. So we need to figure out how did they get from here to here. So I can see the 4a stayed the same here. So we need to figure out which of these properties did they use to get to our answer. So remember, commute just means they switch things around. Well, these aren't exactly the same. Doesn't have the same numbers. All of a sudden we have an 8 in here. So I don't think they're using commutative properties. And these are all added. So we're not using multiplication here. So did they just move parentheses? Well, no, this one has parentheses. This one doesn't. So let's see, did they distribute? Did they give the 4 to the a, 4a, give 4 to 2, 4 times 2 is 8 b's. So it looks like here they used the distributive property to give the 4 to the a, give the 4 to the 2b. So now let's see, we have 4 a's plus 8 b's plus 4 a's. So here's this here. So now they took 4 a's plus 8 b's plus 4 a's and rewrote it as 4 a's plus 4 a's plus 8 b's. So we're not using multiplication, and they didn't give anything or pull anything out. So it's not the distributive property yet. So we've got to decide, did they just switch things around or did they group things together in a different way? So when we're talking about the associative property, we should see some parentheses. Commute just changes the order. 4 A's, 4 A's. So they just change these orders. So then they use the commutative property. So now we have 4 A's plus 4 A's plus 8 B's. Now it looks like we have some parentheses. So we didn't just move parentheses, we gained parentheses. So they noticed that 4 plus 4 had A in common. So they pulled out the A's. So they used the distributive property now. So they pulled out the A's. So they had the A in common. So we're left with 4 plus 4 plus 8B. So now we have 8 A's plus 8 B's. So it looks like they combined the 4 and 4. So we combined our 4 and 4 to make 8. And so now we have 8 A's plus 8 B's. So we also here, you can see the A is in front of the 8. We don't like to write problems like that. We always like to put that coefficient first. So here they use the commutative property of multiplication to flip these around. And instead of saying A groups of 8, we want to make it A 8 A's. Those words are very similar. So I know that is kind of confusing. And I'm sure right now you're like, whoa, what is she doing? I promise we're going to practice more and I'll keep walking you through them. So pretty much we just need to know these so that we're not making up mathematical rules. We have to follow the right steps here. So first we gave 4 to A and 2 B. Then we just switched some numbers around. We have all the same numbers. We just put the A's together and then the B's. Then we pulled out the A. We factored out the A. And we have 8 A's here. So we're going to compare that to 8 AB's. So they took 8A plus 8B and turned it into 8 AB's. So we need to see, are these the same? So up here, let me get a pen here. So we have 8 A's plus 8 B's. We could even take this one step farther and use this distributive property here. So we can see we have 8 and 8. We're pulling out the 8 that's in common, the factor 8. So what am I left with? A plus B. So again, we use that distributive property to pull out the 8, the factor that's in common. So I can see to get from here to here, these are all the steps I would use. 8 groups of A plus B, 8 groups of A plus B. So these ones are equivalent. So this problem is exactly from task 2 that you can follow through to choose the steps here. So these ones are equivalent. Hey, let's try the next one on your homework or on your lesson today. Asks, are these equivalents? We have 8 groups of X plus Y and 5 groups of XY and 3XY. So we're going to start and use the distributive property to pull some things out here. So we want to look at these and decide, what do these have in common here? So what factor can we pull out? So these have, so 8 and 5 don't have a number in common except for 1. That's not really going to help us change anything. So we can pull out, they both have an X and they both have a Y. So we're going to pull out the X and the Y. So what am I left with here? 8 plus 5 here. So we have XY groups of 8 plus 5. So now we want to combine like terms. We don't have any more X's. We don't have any more Y's, but we do have these numbers we can combine. So now we have XY 13. And then we want to use that commutative property of multiplication to rewrite it in the best way. We always want the coefficient in the front. So now we have 13 groups of x, y. 13 groups of x times y will give us that answer here. It's the same thing as y, x times y times 13. Because remember, we can change the order of multiplication and get the same answer. And then here we have 3xy. So we have 3xy's and 13xy's. Are those the same? No, because this one is going to be times by 13. This one's only times by 3. So these are not equivalent. Okay, so here we have this triangle, and one side of the triangle is S, the other side is S plus 1, and the other side is S plus 2. And we want to simplify this. So we want to combine anything we can that's going to make this easier for us to do. So they went ahead and changed it. So looks like they've moved the parentheses. So they took parentheses around S plus 1 and moved them here around the S and S. So when we are moving parentheses around addition, which of these properties associates different parts of the problems together? So the associative property of addition, so they associated the S's instead of the S and 1. And we can do that. We've already proven that can equal the same thing. So now they're turning it in from here to here. So now we need to look and see, now what have they done? So the S plus S is the same. Here's S plus 2, and looks like they've brought plus 1 to the other side. So which of these properties can move an addition problem? So the commutative property can change the order and still equal the same thing. So now they've taken and we've grouped the S and the S and the S's all together. So we're associating all of the S's together. So that's the associative property of addition. And so now they factored out this S. They pulled out the S. So what are we left with? Just 1. So remember, even though we can't see them, there are invisible ones here. This is 1S, 1S, 1S. So we pulled out that S. So which one of these pulls out the factor or distributes it out? So that one is the distributive property. Then we can add our like terms. So 1 plus 1 plus 1 is 3 groups of S, 3 times S, plus we have our 1 and 2 here, which are just numbers we can put together. So we have 3 times S plus 3 more will tell us the perimeter of this triangle. So this up here, this really long expression, can be simplified down to 3 S's plus 3. So if I'm doing a problem, this is going to be a lot simpler to do than having to do all of these steps. So this and this, they are the same, they're equivalent, but this is a simpler version of this expression. Okay, so go ahead and make sure you have completed everything on task 3, and then come back when you are ready to do the problems on task 4. Okay, so are these two expressions equivalent? So we have 6W's plus 2Z's plus 4W's plus 7Z's and 8W's plus Z's. So we're going to start here and we need to see what did they do. So we took 6W's and 3Z's, 4W's, 4Z's, and rewrote it as 6W's plus 4W's plus 3Z's plus 7Z's. So it looks like they changed the order to put the W's together and the Z's together. So which of these properties changes order? So when we're adding, so we're going to use the commutative property of addition here. So now we have our W's together and our Z's together. So now it looks like they're adding in those parentheses, and they pulled out the W's and we're left with 6 plus 4. And then they pulled out the Z's and we're left with 3 plus 7. So which of these is grouping and pulling things out to give to different parts? So that one is the distributive property. They distributed out the factor. So they pulled out the part that they have in common. So the distributive property, remember, can go two ways. You can either find the group or make the group. So now we have our distributive property, and now it looks like they have done 4 plus 6 and 3 plus 7 to make 10 and 10. So they combined their like terms. And now we can see that, so here we have 10 W's, so we want to use that as a commutative property, and we can rewrite this as 10 W's plus 10 Z's. So now we're going to look at this other one here. So we have 8 W's plus Z. We can go one step farther here and use the the distributive property one more time. And we can pull out that 10. They both have 10 in common. What are we left with? W plus Z. Well, this one is 8 groups, and this one has 10 W's plus Z's. So these are not going to be equivalent. Oh, should have pulled my thing down there farther. So adding on like terms there. So not the same here. So this one was 10 W's. This one was 8 W's. These are not going to be the same. So go ahead and complete task 4. So I know that was really long and a lot of new information, but we're going to keep practicing, and we'll find some steps and some strategies that can help make those easier for us. So go ahead and get your lesson done and try the check for understanding today. So use those rules, all those properties, to answer those questions. There's just 2 check for understanding problems. And if you need any other help or questions, please let me know.